So this video's topic is recursion. Before I give you an example of an algorithm using recursion, I will define recursion and I'll give you an example of an algorithm without it. And then later we will work our way through to convert or to write now an algorithm that does the same thing but using recursion. So first of all, recursion, what is it? Recursion happens every time an algorithm calls itself. So we are talking about a function or procedures. So if I have a function A and function A inside itself calls function A again, then we have recursion. It's basically it, a function calling itself, a procedure calling itself. So let's see some examples of algorithms without recursion. So let's suppose we have this problem. Print the first 10 natural numbers from the biggest to smallest. So it means we are going from 10 to 1 and not going up. We are going down. We can start writing our algorithm like this. So first we need a variable. Let's call this variable a type integer. We know it's a number. Let's set this variable to 0, and then we need a loop. Let's use a for loop first. So the loop will run for a equals 1 until a is smaller than 11. The loop will print a, and that's pretty much it. So at this point we wrote an algorithm that writes on the screen, on paper, it just prints the variable a. Variable a is going from 1 until 10. The value of variable a is changing from 1 until 10. Okay, fair enough, but we don't actually need to set the variable to 0 in the second line, right? So also there is a problem here because the for loops, they just grow the variable. So a is equal 1 until a is smallest than 11. We cannot use the for loop to go from 11 to 1. Okay, so we have to actually change the logic of this algorithm. It would be easy enough to just print 11 minus a. So if a is 1, we will print 11 minus 1, 10. If a is 2, the next iteration of our loop, it will be 11 minus 2, and we would print 9. So this algorithm is not a recursive algorithm. We are not using recursion. It's just using a normal loop. Of course, we can do the same thing with a different loop. Let's suppose we want to use a do-while loop. So we will perform the loop, we will do the loop while variable a is bigger than 0. So we print a in this case now is equal to 10, the second line, and then after we print a, we change the value of a. So we just subtract 1, and then a now is equal to 9. We go to the do while line. Is a bigger than 0? Yes, a is 9. Then we print a, and then we subtract 1 from a again. A is equal to 8, and we keep doing it until a is 0. When a is equal to 0, the do while line will be false, and then the algorithm gets out of the loop. So I'm giving you these two algorithms to illustrate an example that is not recursive. So it's just straight. Both the for loop and the do while loop, both algorithms are doing exactly the same thing in different ways. Non-recursive algorithms. Okay, so let's get an example. Let's get an example of a recursive algorithm. So a very famous recursive algorithm is the factorial of a number. So what is the factorial of a number? The factorial of a number is the multiplication, factorial of a number is the result of all the multiplications of all numbers below that number. So, for example, the factorial of 4 will be 4 times the factorial of 3. The factorial of 3 is 3 times factorial of 2, factorial of 2, 2 times factorial of 1, factorial of 1, 1 times factorial of 0, and factorial of 0 will always be 1. Okay? So, in our case, let's bring it to the algorithm world. We could write a function called myFactorial, for example, and that function will receive an integer. So if we want the factorial of 4, in this example, if a is equal to 4, we would call this function from within our algorithm like this, myFactorial 4. Then the result of this function will be the factorial of 4. But what happens inside myFactorial is that we need 4 times and we need to call it again. We need the factorial of our number minus 1. So we are actually doing 4 times the result of the function myFactorial for 3. And that, in turn, we'll be calling factorial again because we need to do 3 times the factorial of 2, and then it goes again and again until we call myFactorial 0. And then when we call that function myFactorial 0, we'll always return 1. So just take a look at the left side, factorial of 0 is 1, and then when the function myFactorial with 0 as the argument finish executing, it will return the result to the main algorithm. Okay, so let's make it happen. Let's write down the inside of our function myFactorial. So here is our skeleton, here is the structure of our function. So function myFactorial, it receives an integer and then we end the function. Okay, so we know when the factorial will finish. The factorial will finish when the variable, when we are asked a factorial of 0. So if a, our variable, is 0, then we already know the result. We already know what to return. We will return 1. And that's it. So the first thing we write in a recursive function or recursive procedure is the ending statement. We know it will finish myFactorial integer, myFactorial receiving an integer. This function will always finish when the variable is 0. Okay, and then if it's not 0, what if it's 1, 2, 3, 4? If a is anything other than 0, then the if will fail and we go to the next line after the end if. So the next line after the end if, return a, our variable, times the factorial of our variable minus 1. So I hope that at this point you can understand what's happening. What we are doing is we are calling the function again, but we are passing a different number. The number we have minus 1. And that will keep happening until a is equal to 0. When a is equal to 0, the function returns 1 and then everything goes back. So, for example, if a is 1, let's suppose a is 1, the first run it goes to return 1 times myFactorial of 0. We know that myFactorial of 0 will return 1, so we are actually returning 1 times 1. Okay, so what do we write as the answer of our algorithm, the first algorithm? that we put before. Print the first 10 natural numbers. We have the function. We check when if a is bigger than 0, we keep calling it. If a is 0 or less, we'll just skip, and then the function will finish. So if a is bigger than 0, we'll keep calling the function over and over, and then we can just write this as the answer of our problem. So to print the first 10 natural numbers from the biggest to smallest, we would call my function with argument 10. Looking at the left side, my function the first time a is equal to 10, a second line, a bigger than 0, yes, it prints 10, and then it calls my function to 9. It goes again, it goes print 9, call my function to 8, prints 8, call my function to 7, and keeps doing it until 0. When it's 0, it just returns everything. So only that call would be the answer to our question. So, but of course, we are always looking to write algorithms that are scalable. So let's change that. Let's erase that 10 and let's write it n. Let's assume we want to write a function that will, or write an algorithm that will print the first n natural numbers from the biggest to smallest. So we already wrote a recursive function, my function, that will do that recursion. So an algorithm to solve this problem would be as simple as this. We print, please insert a number, so the user knows that he needs to insert a number. The user inputs a number, and then we call my function with that number. We print all the numbers because that's what my function is doing, and then we print thank you to our user, and that's the end of our algorithm. So that's pretty much it. Recursion is not a difficult topic, but it might be difficult to understand what's going on. Always remember, if you have to write a recursive function, the first thing you should take care of is the stopping criteria. The first thing you write inside your function or procedure is the final statement, the point where the function or procedure stops working and starts returning results to whoever called it before. Okay, that's it. Thank you very much.